So we're still talking surface area, but instead of talking about prisms, we're talking about triangle and pyramids. And we're in there. Pyramids and cones, okay? So a pyramid is a polyhedron. Polyhedron. Remember, poly means what? Multiple, many, okay? It's kind of like polygon, many-sided figure. This just means it's a figure made of polygons. Okay, so each side is or each face is a polygon. So in this case, we've got triangles, and this is a square. Okay, so in which one face, which we call the base, can be any polygon. Okay, so the bottom, the base of a pyramid can be any polygon. In this case, this one is a rectangle or a square. It could be another triangle, it could be a pentagon, it could be an octagon, it could be whatever. Okay? And the other faces, the lateral faces, are going to be triangles. Just like yesterday, we were talking about the prisms, all the lateral faces had to be rectangles. With the pyramid, they all had to be triangles. And they all need a common vertex. Remember, vertex means corner. In this case, vertex means the top point of the pyramid. Okay? So the base, bottom can be anything. All the lateral sides have to be triangles when it's a pyramid. A couple different things when we're looking at a pyramid that is really, really important is that the altitude or the height of the pyramid goes from the middle of the inside to the vertex. Okay, so you can kind of see, try to show here. I have a piece of string that goes from the middle of this guy to the top. This would be the altitude, this would be the height. However, we also have a thing called a slant height. Slant height goes along here. If I was going to draw a line right on the face, right on the triangle, this would be the slant height because it is slanted. What's the altitude again? Altitude goes from the middle, the bottom, to the top. Okay? Slant height goes along the side. Okay, you see how they are different lengths, right? Why did you put those strings
Here.
Alright, so as soon as around, I want you to look at it. There is a difference. Slant height goes along here, height goes from the middle to the top. Okay? Pass it around. See how it's different. Regular pyramid. Base is a, I don't remember. Base is a square. Yes. Lateral faces are triangles. Okay, slant height. Let's talk about it. Slant height usually is represented by a cursive L. Slant height. Okay, it's the length of the height. It is slanted. It's the name of slant height. Okay, notice that if I take the altitude, the actual height of the pyramid that goes from the top corner to the bottom, and I have the slant height, and then I connect them, I have a right triangle. Okay? Usually you're going to have to use Pythagorean theorem because either they're going to give you the slant height and you need to find the height, or they're going to give you the height and you need to find the slant height. Usually either one or the other.
Can you round when you do it?
Probably. Yeah, depends on what directions. Alright. Lateral area, just like yesterday, it's not with the faces, it's all the other sides. So it's the sum of the areas of lateral faces, meaning all the triangles. Okay, so the area of one lateral face, meaning one triangle. If we look at the net over here, remember net is like if I was going to cut this out of here and fold it and tape it together, I would get a pyramid. So here is the net, the one that you guys have up here. So here's the net. If I was going to fold it up, we get a pyramid. Okay, so they've just kind of split it, kind of like a, I don't know, a banana, I guess. They just split the edges and they split it out, okay? Like this. Okay, that's one way to make it out. We could put it a different way, but this is the way they've done it. Okay, so notice that we've got 4 different triangles, so we've got 4 different sides, right? Okay, if I was looking at this, if I was going to find the area of one triangle. How do we find the area of a triangle?
Area of base time. No, area equals half times base times.
Half times base times height. Okay? So if I think about it, if I fold this guy back up, like this, and thinking about it, if I want to find the height of the triangle, not the pyramid, the height of the triangle, what would it be? The slant height. Okay, the slant height is going to be the height of the triangle, and then the base is going to be our base edge. Okay? So if I have the area of one little base, it's going to be 1/2 times the bases, they call it S, where S is the base edge, times the height, which is the cursive L slant height. So, there are two different ways of thinking about finding lateral area. You can either take the number of triangles, a number of triangles times area of one of them, because in this case, since I have 4 triangles, because I have a 4-sided base, that means I can just take one of the triangles, or one of the areas and take it times 4 to get the lateral area, right? Okay? Or you can think it's the same as.
Can I interrupt for a second?
Sure.
I'm going to be passing around a card here. This is for Coach Meyer. Just a thank you for him for coming and speaking to.
Alright, so we can think lateral area is number of the triangles times the area of 1, or 1/2 times P times L. Okay, so what do you think P is going to stand for?
Perimeter.
Perimeter of what?
Triangle.
So base and L is our slant height. Switch obviously. Okay, so it's really similar to what we were talking about the prisms yesterday, where we had the perimeter of the base times the height. Where in this case we have half times the perimeter, because it's a triangle, we want half times the perimeter of the base times, instead of the height of the pyramid, it's the slant height. Questions so far?
Okay, so when it says the perimeter, it's meaning like the whole perimeter of the base. Like if one side was 2, then it'd be half times 8.
Right.
Okay.
Yeah. Surface area is going to be our lateral area, which we said was 1/2 times P times L. Now, yesterday we were talking about prisms, we said plus 2 big B. In this case, what do you think we're going to add on? Times 1B. Yeah, only 1 big B. Because how many bases are there? Okay, so just lateral area plus B, area of the base. Alright, let's see if we can find anything. It always makes sense. Asks us to find the lateral and surface area. It tells us that we have a square base. Notice that they have given us one side. This 4 centimeters goes from corner to corner. That's what they're labeling here. Kind of sometimes it's hard to tell. And this 6 is what? The slant height. The slant height. Good. Alright, so we're going to find lateral area. Our little formula says 1/2 times P times cursive L. Alright, so what is P? 16? Because we've got 4 plus 4 plus 4 plus 4. 4 times 4, right? Okay, what's up? 6. Okay, so I would think half of 16 is 8. What's 8 times 6? I think that's the easiest way to figure that one out. So lateral area is 48 centimeters squared. Okay, now let's do surface area. Okay, surface area is going to be our lateral area plus big B, which we've already found. Alright, how are we going to find B? times 4, because it's a square, base times height, so 16, you're right. Which would give us what? 60 something, 60,
64.
yes. Alright, part B says, find the surface area of a square pyramid with base edges of 7.5 feet and a slant height of 12. Well, they don't give us a picture to look at, but they can tell the information that we need. Okay, so they ask us to find surface area, not just lateral area. So our formula, we'll have here. If we wanted to, we could draw a picture. So it tells me that I have base that is a square. So you kind of have to make kind of a rhombus looking thing. It's not a very good one, but you guys get the idea. And then we're going to find kind of the middle and go up and make a dot. And you're just going to connect from corner to this dot. Right. And we can draw so the base edge of 7.5 feet and a slant height. If you ever have a desire to draw a pyramid, that's kind of a do it. Is everybody sign the card? All right. So if we were to fill out due to what we know, finding the surface area, what's our perimeter? Is it 30?
Pretty sure there's 7.5 times 30.
Okay. Because remember, yeah, this is 7.5, 7.5, 7.5, 7.5, because it tells us it's a square. So 7.5 times 4. What's our cursive L? 12. This is slant height. What's our big D? Good. Which is, I don't know.
56.
So let's see. I probably go, doesn't really matter because I'm just using a calculator anyway. Half of 30 is 15. 15 times 12. 28. And then just add in together. Alright, everybody good so far? Okay, let's go on. Also, the Great Pyramid at Giza, Egypt, was built about 2,580 BC as a final resting place for Pharaoh Khufu, I think is how you say that one. At the time it was built, the height was about 481 feet. Each edge of the square base was about 756 feet long. What was the lateral area of the Great Pyramid? Okay, and do you know with the Great Pyramids that they used to be covered in limestone? No. But it's all been taken and stripped away by robbers and people get away and whatnot. But anyway, okay, so they give us the height, but they don't give us the slant height. Because remember when we're looking for the lateral area, we need 1/2 times P times L. So we're going to need to figure out what our slant height is before we can figure out what the lateral area is. How are we going to do that?
We use the diagram to figure out that we find BC, we have to cut 756.
Good, yes, because this only goes halfway to the edge. edge. So Casey's right, it's only half of 756, which would be
378.
378. Okay, so we're going to use our Pythagorean theorem. They are really big numbers. I wrote too big. And I'm afraid that we're probably going to have to do some rounding on this one. Because I think that it was super ginormous decimal, if I remember it. That's 11.76, that's what people came up with. Make sure I did it right. Alright, okay, so if we go back over to our lateral area, how are we going to find P? 756 times 4. Make sure that you're taking it times 4 and not times itself, because that would be big B, right? We're looking for perimeter, we just want to add all the sides together. Times length height. So then you just plug everything in your calculator. So this is how much limestone it would take to cover the outside. Oh, yep, you're right. Thank you. Please, right. For this area. And we're also going to talk about cones today. So a cone, like an ice cream cone, upside down. Okay, so just a cone. Is a pyramid with a circle base. So it's kind of like yesterday where we had the cylinder, and a cylinder was just like a prism with a circle bases. Cone is like a pyramid with a circle base. So in a right cone, the altitude is the perpendicular segment from the vertex to the center of the base. Just like we were talking about with our pyramid, we're looking from the top to the middle. Okay, so from the middle to the top, that would be our height. And again, we still have a slant height, just like we have with the pyramid. Slant height goes on the outside. So slant height is the distance from the edge. No, excuse me. I'll go backwards. From the vertex, which is the top point, to a point on the edge of the base. So if you were going to look at the net of a cone, it looks something like this. Okay? Yes, sure, I suppose. Okay, so we've got the bases are circled in here. What does the lateral area kind of look like?
Half a circle.
Kind of looks like half a circle. Or kind of looks like a fan, or
Goes ahead.
kind of like a triangle, yeah? Okay. So in this case, if I'm looking for lateral area, how do we find if it was a pyramid?
Half times vertex times out.
Times slant height. So we're going to do the same thing, same idea, except since we're talking about a circle base, if I'm looking for P, we're really talking about
Circumference.
circumference. And how do we find circumference?
2 pi r squared. 2 pi r.
2 pi r. 2 pi r. Okay, times, so we're still taking times the slant height versus now. So circumference. And slant height. However, what's going to happen over here when I take 1/2 times 2? Yeah, they're just going to cancel out. So we really don't need one in there. So we can just say, or lateral area can just be pi times r times l. So 1/2 and the 2 are just gonna go 1. That's really fast. Alright, so surface area. So like with a pyramid, it's going to be our lateral area, which in this case is going to be pi RL, plus big B. Well, if our base is a circle, how do we find big B? Pi R squared. And our last couple examples say, on a surface area of the cone, leave your answer in terms of pi. Alright, so if we're looking at this cone, surface area, and this is another one of those formulas that you're probably going to want to have memorized, just FYI. So we've got pi times r times L plus pi r squared. So did I work here? Yes. Alright, so what's our R? 15. 15. What's the L? 25. They didn't go to someone else next to slant, right? Plus pi and then R squared. You don't know what 15 times 25 is. 375. Plus 15 squared instead of 225. Okay, add them together. Ooh, let's see.
600.
Okay, how come it's going to be just a little bit more difficult? Yeah, we better do the Pythagorean theorem because they give us the altitude, they give us the height of the cone, but not the slant height. So we need to use the Pythagorean theorem. I was looking at it, we know this is 7.5.
We know that the radius is 4.
Good, this is 4. Right? So I would go 7.5 squared plus 4 squared equals L squared. You guys figure that one out for me. So come on, that's Stephen. I'll take your word for it. Alright, so now we can fill out our formula since we know all our pieces. So our radius is 4, slant length is 8.5. I don't know what 8.5 times 4 is.
34.
34.